Hello everyone. So this is going to be a video tutorial for the Northwestern Ideal Lab Metamaterials Data Explorer website. So as you can see, this is our current link. So you can follow along by going to this link as well. So what you see here is the landing page and also what we call the pairwise plot. So this is a pairwise plot that has 6 by 6 dimensions, and each dimension is a property of the metamaterials. So there are 6 in total. There's C11, C12, all the way up to C66. And the way you read this plot is choose a y-axis, and then you choose a x-axis. And then, for example, if I choose C11 and C11 again, I will be looking at this plot. And then if you hover over this plot, you can see there are some stats regarding this plot. The diagonal plots in this pairwise plot is a histogram because these will be about the same attributes. So this one shows the distribution for C11 and this shows the distribution for C12 and so on. And the rest of the plot is a scatter plot which maps two different metamaterial properties onto the same plot. So if we choose this one, which is going to be C22 and C12, you can see this one has the data set once we hover over it, and we also have the symmetry. And you can see as I hover over the points, on the right here, the Young's modulus and Poisson ratio constantly flickering, and also the unit cell geometry. These three plots will change according to the places that I hover. So if I stop on this point, all of these 3 points will represent the 3 attributes for this point, and it will continuously update as we change our focus point. So on the right hand side here, this is what we call a sidebar. So you can also hide it if you want more space. Currently we're not sure what kind of information we wanted to put here, but this is a function that we have. And you can obviously upload data here and download a template, and here is all the data set that we have. You can toggle the check mark to display and hide the current data set, and you can also click on this arrow here to see some more information about each data set. Right now, the description are kind of a boilerplate, so it's not specific to the data set, but we will update it once we have the relevant information. So here, going forward, the property range is a slider. So the numbers here are shown as the minimum and the maximum of each property, and you can scroll like this and you can see the points. The pairwise plots will change accordingly, and if we have placed the marker, the slider in a position such that it doesn't include extra data sets, it will uncheck automatically the data sets that are not included in this range. So for example, in this example, there's only lattice 2D example included. So every other data set is automatically unchecked. And we can bring it back. But as you can see, once we bring it back, you kind of have to manually include it by checking the data sets. So now we're back to the original state. And here we have some material information. This also updates according to each point. As you can see, as I hover over the points in the scatter plots. So yeah, that is mostly everything about the homepage. Now, you can probably see that once I hover onto one of these boxes, it gets highlighted. So what you can do is you can actually click into these. So let me try one of these. So if I click on this one, it will take me to a scatter plot, which is the zoomed in version of the scatter plot that you just saw in the pairwise plot. And here there's, on the right side is pretty much the same. The only difference is that you can choose the axes of X and Y here. So let's just choose something that looks reasonable here. Okay, so you can see there's 3 buttons here. What you can do now is that there is a nearest neighbor function. So if you click on this any point, it will show the 5 nearest neighbor in regards to this point. And it's only showing 3 because there are actually 2 points that are overlaying each other. You can see the red one and the green ones are actually the same point because the distance is 0. And then obviously you can download and then you'll see this is what the downloaded data looks like. So once we X out of the nearest neighbor, we can try to reset, and there's another function here that says save data. So what you can do is if you want to further inspect some of the data here, you can click and drag, and you can see all of these points will be selected, and you can click save data here, and all of the data that you just selected will be displayed on this panel here, and you can download, or you can I think this button is for reset, but apparently it's not working. We'll try to get it fixed. Yeah, so once you download the data, the format is the same as the KN downloaded data. And yeah, so that is the individual scatter plot. So if you wanted to go back to the home page, you can click on the header up here. Once you hover over it, your cursor should change to like a pointy hand, and then you can click on it to go back. So I've shown you the scatter plot, and we also have a histogram. So you can also hover over it. Once you see the highlighted edge, you can click on it, and then that takes us into the histogram. So the histogram is only has only one property, so there's no X and Y. The Y in this case is the frequency of the property that we are inspecting. So you can hover to see the distribution of each data set, and then there's 3 dotted lines here. So these lines represent the mean of each data set. So if I change to something more obvious, so the orange data set, freeform 2D example, has a mean right around probably like 600 to the sixth for their mean, and then the other two means for the two data set are also dotted around here. You can also read the tooltip here, so you can get all the information about the data sets here. If you unselect, it will also update this tooltip. So another handy feature is you can do a significant number change. So you can see I just turned on the 10 to the 9th power, so everything will be converted into 10 to the 9th power, and I can toggle it back to 10 to the 6th. And on the right side, again, this is just pretty much the same. So yeah, that's everything you need to know about the histogram. And there's one last page that I want to show you, which is the what we call the UMAP reduced dimension, and you can access it from the home page here. So it takes a while to load because if you're familiar with the UMAP reduced dimension, it's basically trying to take data with multiple dimensions. So the page that we just came from 6 by 6 dimensions and trying to reduce it into 2 dimensions. And the numbers here actually don't mean anything, so that's why we didn't label it. But we put the tooltip on regardless, just so you kind of have an idea of how it works. So this actually has very similar features compared to the scatter plot, as you can see from the UI. So you can find nearest neighbor, same thing, and you can also save data as well. So one thing to note about this hyperparameter tuning here is we have a number of neighbors. So what this means is that so in the calculation of UMAP, it's calculating the reduced dimensions based on number of neighbors. So this one is actually separate from the nearest neighbor function in the bottom left here. So this is purely for the UMAP calculation. So if you say putting a different number, let's say 10, you can see the plot will update automatically. And then if you also want to drag, it will also update itself based on the number of neighbors. So you can see it's more sparse right now because the number of neighbors is very small, so each points are scattered in smaller groups. So that's pretty much it about the UMAP page, and everything else should be pretty familiar to you right now. So that should conclude this tutorial, and please let us know if you have any more questions. Thank you.